Where did it come from? Yeah, when and where?
All right.
Don't tell me right now. You know. Dude, tell me. Is it?
All right, work.
Keep switching.
What?
No, it's fine.
All right. Today we are going to start with work. This is the work energy chapter.
Is this one also hard?
Yes.
You said only the first two were hard. You said they were not hard.
Okay? Nothing in physics is easy.
Well,
What?
a group of machine.
What did you say?
A group of machine.
That's not easy.
I
I
wanna
get
try
people
that.
that don't get that right and get C's all the time.
Wait, what do you mean don't get it?
Oh, cool.
They
The great
don't,
projects.
they don't get the can open.
Oh,
3 tries.
Oh,
Oh, the whole class?
No.
Oh, you do an individual project.
Oh, so as long as your part works, it's fine.
Dude,
Yeah.
just
No, this is not talking. I'm not talking about the final. I'm talking about the individual group project.
oh, we do 2?
Yes.
Oh. Rubber go blur.
So in everyday sense, the term work means something different than what we would say work is from a physics standpoint. Work from an everyday standpoint means what?
Doing stuff.
Doing stuff. I'm doing work, right? Okay, a lot of times it's referred to physical activity. You could say mental work too, though. You could say a lot of different things from an everyday standpoint of work. From a physics standpoint, work is very much different. It's very specific. Okay? It's not just, oh, I am doing something of physical labor. Because in physics, you could be doing something that is very, very difficult and very, very physically strenuous, but it not be physics work. For example, me sitting pushing on this wall as hard as I can for as long as I can is not physics work. Okay? So we need to be able to figure out and define what physics work is. Do you guys have an equation? Alright, so there it is. Alright. So work is done on an object when a force causes a displacement of the object. So why am I not doing physics work right now? It's not being displaced. Okay, so I'm not doing physics work.
Wait, so if you push it and then push back to the spot where it started, does that technically not work? Push displacement is 0. Like if I push this and push it back.
The work done on that object would be 0. Yep.
So basically,
Yep.
like why? So basically, movers have no choice.
They do no work. Yeah. Movers do no work. Okay. Another example of not having any work done would be me sitting and holding this chair like this. Why is no work done?
Actually, technically,
It's moving.
you moved it from the ground.
Okay, but I didn't say the process of going from the ground up. I said right now. Is there any work? Am I doing any work on the object?
No.
Kinda.
It is kind of moving a little bit. It's very difficult to not move that. Okay? Work is done only when the components of force are parallel to the displacement. What does that mean?
You only have enough force to move it. How
Can't
far
push
you
it in that direction, doesn't move.
Well, I could take this chair, which is not a great example, hold it like this and walk. My arm is doing no work on this chair. Why?
No force.
That's not.
There's a force there.
Shares. Because the force your arm is not parallel.
Yes. Say that louder.
The force you're doing with your arm is not parallel to the displacement.
Which direction is the chair moving? Yeah, horizontally. Well, what direction is my force that I'm applying on this chair?
Vertically.
Vertically. Now, there's a different force that's causing this movement, but the force of my arm on this is not doing work on the chair. Understood, yeah?
If you dropped it, it would be work.
If I dropped it, gravity would do work on it, yes. Yep, or if I take this and lift it straight up, I'm now doing work on the chair because the force is in the direction of the motion.
But if you set it back down, it's
What an awkward definition.
No, if I set it back down, that's work. Well, that's
And the
not.
same thing. like-
That would be different because that would be a net force because you'd have gravity and your applied force. You still have work, I guess. Okay?
That's the measure.
Now, this next slide is showing you how if you were to take, if there was a box, let's just say this is a box. Let's use this as a box. And I push like this.
That is one of the more
Okay.
sensitive.
I am doing work on the box. That force is doing work on the box, but not all of the force is doing the work. What do I mean by that?
The wheel.
Because you're pushing
X
that.
component is on.
Only the X component of that force is doing work because there's a Y component as well, which would be perpendicular to the motion, wouldn't it?
Yeah.
So if I apply a force downward, then the X component is the one that's parallel to my direction it's moving, but my Y component has no impact on that motion. So for example, would I be able to push that cart better if I was applying all of my force in the X direction versus only some of my force in the X direction?
Yeah.
Yes. Okay? Because if I'm applying at an angle, the Y component is really just pushing against the ground, which is not really pushing the cart, is it? If a force is pushed, the Y component is really just pushing straight down on the ground. Okay? So there are two things that you need for physics work to be done. What are those two things?
displacement.
Force parallel.
Force has to be parallel, either a component or the whole thing, and it's got to cause a displacement. So if you were to write this, required for work to be done. You've got two things that are required for work to be done. You must have a force. You could say three things. You could say a force. Force has to be in the direction, but I'm going to put those two things in one. So I'm going to say force. Oops. For. I shouldn't say in direction because it could be opposite direction and still be parallel, right? So force parallel. I don't know how to spell anything, guys.
P-A-R-A-L-L-E-L.
And secondly, force what? Or needs to have a what?
Displacement. Displacement not equal to 0. Displacement not equal to?
Okay? Did I really do an E and a C?
Fork.
Man, I'm struggling today.
I also never realized
That's it. There must be something here about sign conventions, isn't there?
The sign of work.
Okay? So, I must have put that in there out of the book. Okay? It gives you sign conventions for work. Okay, you've got positive work, you've got negative work. Now, the interesting thing about this is work is actually a scalar quantity, but you can still add work or lose work. So the sign there is not really as much. I don't know. I would kind of disagree. I kind of think work is a vector quantity, but I don't want to say that, and then you guys.
So that's probably not.
So what about the test?
So follow the fact that it says it's a scalar
Yeah, I
quantity.
want to say by quote, by. I mean, yeah.
Test question?
No, but
No, I know, I got work together. I never.
Okay. So, if a car is driving east and it applies the brakes, okay, the brakes are going to be doing a force that causes the object to decelerate. So that would be a force in the opposite direction, therefore negative work. Okay? Or let's say an object's coming towards me and I apply a force in the opposite direction of the motion to stop the object, I'm applying a negative force. So really in this context, negative and positive doesn't mean direction, because it could be coming at me in the positive direction, I can slow it down. It could be coming at me in the negative direction, I could be slowing it down. In both cases, the work is what? Negative. Everyone understand that? Okay? It could be coming to me in the positive direction, and I can be slowing it down, or in the negative direction and slowing it down. Both cases, work is still negative, regardless of the direction. So that's probably why it's scalar. Okay? Because work. Although I will argue, just because work in and work out could also mean
So,
positive or
no
negative.
matter the way you're going, if you slow it down, it's gonna be negative.
Yep. Yep. No matter what direction you're going, if your work is slowing the object down, negative. Okay? If the force you apply causes the object to accelerate, and you're following those two rules there, it's going to be positive work. When is it no work?
When it's not moving.
When it's either not moving or
You're not pushing it correctly.
force is not parallel, or force is not parallel, or you could just say force is perpendicular. Okay? Let's do a problem.
Mr. Kramer,
Yeah, oh, there it is.
what does force at a 90-degree motion?
So like, let's say your change in x is that direction, and you're applying a force in that direction. It would be a 90-degree perpendicular. So you would have, your force is perpendicular to where you're going, or where the object is displacing. Does that make sense? So like if you were to put that into your equation, which is work is force times displacement, cosine of 90 is 0. We figured that out last chapter, right? Cosine of 90 is 0. Cosine of 0 is 1.
All that bugs me to put displacement as D, not X.
You could make it change it. Okay?
I didn't try.
So work.
It's starting, guys. I'm starting to get sick.
No.
This is the longest I've ever lasted without getting sick.
So you say work equals force times split.
It's right there.
Gotcha.
Cosine of theta. Okay, so if you guys didn't notice in your note packet, it has work equals force times, displacement cosine of theta. The cosine of theta is going to take into account the component of force that actually is causing the work.
So, you said you could change you put the negative. So it's going to
Yes.
Shoot, what's the?
No,
Well-
that's not what they're gonna do. That's wrong. They did define that.
No. Well,
It's right here. WFT is
Is it in the book? Oh, I did it right then.
I'm trying to remember now.
Wait, you don't have to solve.
I would always choose sine based on whether it's speeding or slowing down versus. Yeah, I don't think you put the sine
Yeah,
in
because I
first.
got 26
So
first.
like
D.
just decide what it is.
Yeah. Yeah.
Do you want to resolve the vector?
That's what cosine of theta does.
Okay. Oh, that makes sense.
Yep. So did everybody catch that? Isaac said you don't have to resolve the vector if it's at an angle. Well, yes, you would, but that's what the cosine of theta is doing for you in the equation.
So that makes sense?
It depends on the context of the problem. Like you should be able to tell from the context of the problem if your force is in the same direction of your motion or not.
What's the?
It will give you an angle if it is.
130.
What was that for? For what? Oh, good question. Let's find the units. Work
It's gonna be
equals force times Displacement cosine. Cosine theta doesn't have units. What's a force unit?
Newton.
What's a displacement unit? Okay, that is the same as a joule. A joule is a Newton times a meter. A Newton is a kilogram times a meter per second squared.
Can we do this problem?
Yep, I do.
Wait, what?
Wait, and you said you
You
could
have one
change,
info on four.
D to change that. Okay.
Sorry, what was that?
You can change D to
30
change S.
degrees.
And what they're saying, I think the reason why they put D is because you're not putting in negatives in this. Okay, because work is going to be based upon whether or not you're speeding up or slowing down, not what direction you're headed. If that makes sense.
So just keep it.
Yeah, I would think so.
Oh.
Okay. Now, let's read this problem. You said that I'm missing information.
No,
in your
I
notebook?
never mind. It's good to know you're good.
Okay, here we go. Says how much work is done on a vacuum cleaner pulled 3 meters by a force of 50 degrees at an angle. Okay, so we know our D is what? We know our force, and we know our angle. This is pretty simple,
Well, I
isn't
can
it?
shove that back. 100. Oh,
Okay, so if you were to actually do a free body diagram of that, you would say your force is that. Because you're pulling the vacuum at a 30 degree.
Is there a difference in like physics?
Like if the force is different if you push or pull.
Yeah, is there anything like, is there any difference at all?
Nope.
just direction.
What's the matter?
No, even still, if you push it.
Okay, so I want to show you how here we know if I'm pulling, guys, if I'm pulling at a force like this, Cheyenne, you with me? If I'm pulling at a force like this, the motion's probably straight along the ground, right? I'm assuming when you pull a vacuum, it's not rising as you're pulling it. Assuming gravity's going to keep it on the ground, correct? Okay? Now notice, do you see where the cosine of theta comes in here? Cosine would give you the component that's parallel to the motion. And you could do the same thing if it were a vertical force.
This displacement? Oh, wait. Never mind. Keep going.
Well, usually vertical force is just done straight up.
This,
I don't really need to probably elaborate on that anymore. What was your question?
doesn't matter. Keep going.
Sure?
Yes.
Okay. Questions? What do we get for an answer?
130 joules.
Yep.
The next one doesn't have a degree. We have to resolve the final degree.
Well, let's figure out the context of the problem here. That will help us. Okay? So you've got a suitcase is raised 3 meters above a platform by a conveyor belt. Okay? How much work is done on the suitcase?
How do you compare it to lift?
It's basically you're lifting an object straight up.
Does that mean it's not parallel?
It means it's a 90 degree.
Zero, which means
No.
That just means there's no work.
Force, no. Force is up, because you would have to lift up to have an object be raised up, correct? And what's its motion also? Straight up. So your angle in this case is what? 0.
Oh.
Cosine of 0 is 1, which simply says that all of your force is going into doing the work.
Wait,
So
why isn't it 90?
Because, guys, it's
already
0
straight
degrees. There's 0 degree difference between the motion's direction and the force's direction. In this one that I gave you earlier, that's force, that's motion. There's 90 degrees between the motion's direction and the force's direction. Here, the motion's direction and the force's direction is 0 degree difference.
So because it's not moving from here to here, because it's already just going.
It's just going straight up. Force is going up. And think of a conveyor belt. Maybe think of like getting in an elevator. Okay, the elevator's force is pulling straight up, and you're moving straight up. Like, that's essentially what an elevator is. It's a conveyor belt that pulls you up. We haven't figured it out yet. We gotta figure it out. So here's what I wanna say about this. This is really important.
You have
They
weight.
didn't give us the force, but when you raise an object, what do you have to overcome to get it to go up?
Gravity.
And what is gravity in the context of
Weight times.
weight? So to lift an object up, what do you have to overcome? The object's
Weight.
weight. Okay? For these types of problems, you're going to assume that you're going to lift just enough force to overcome the weight and no more. Okay?
So
Because as
it's,
soon as I overcome the weight, as long as I have enough force to overcome the weight, it's going to continue in motion indefinitely.
So which,
So we have to figure out the weight of the suitcase. Here is your weight equation.
we have the weight, 30, 20 grams.
That's the mass. Weight and mass are very different. Weight is an object's force due to gravity, how much gravity pulls an object down. Mass is how much matter you have. Now, do you need the mass to find the weight? Absolutely, but weight can change because what can change? Gravity. Mass cannot change. Okay? Assuming we're on sea level. Okay? So you would plug in
You got it.
20 kilograms times 9.81.
So like when you do that, just like increase it by like 1 decimal point?
Yeah, that's what I was thinking.
Like how much do you overcome it by?
The exact amount.
So like 0.00.
Well, we can assume that, sure. Like, all it takes.
Keep going, I need to see what you do.
Yeah,
You just take
this
this.
question isn't important.
No, this is gonna
So
be-
I get what you're saying.
Yeah.
But if we don't set that as a standard, then what is the force?
Oh, I guess you just do sig figs and then do one more interval up.
Yeah.
Okay, that makes sense.
Okay, what's the number here?
590.
Negative.
Oh, well, no, not
96.
that one. Yeah, yeah, that
96.2.
one's 19. And then.
So I would need to apply that much force to get the object to lift.
So that'd be one
Plus.
I get what you're saying. I know exactly what you're saying,
Yeah.
but if we try to change our interpretation of that, it makes these problems.
Okay.
It's essentially like assuming there's no friction even though it's still there. And assuming there's no air resistance even though it really is there. It's really just to make it simpler.
Okay.
Keep this like 0.0001. Got
It's
it.
going straight up.
Well, you could also say that that wouldn't really affect this number any.
Yeah.
Okay.
Over time.
So, we know that I have to, anytime you're lifting up an object, anytime an object is being lifted straight up, the force you're looking for is always the weight. That's important. Because you have to overcome the weight for you to move vertically. So 196.2, then you're plugging in. Work. 196.2. Displacement.
Like that's right.
Cosine, and we said we are at 0 degree angle. So this just simply means that 100% of the force is going into doing the work.
So I did it.
What's the matter?
Nothing. I did the same thing, but like, I was confused because you said that we got mass, like 28 kilograms.
Sure.
So we needed to change that to weight to
What, I said?
be able to plug that into our FG. But then it's the same again.
You have the same answer?
No, I did that. I already did that. Because that's I already knew that's what
Okay.
But I was confused when you said that you
still like
mass.
Yeah, you do. Then how did you do it? You didn't change all the mass to weight.
Oh,
I said I'm not. No,
Russian.
just-
I'm trying to be stupid, okay?
Is there mass?
Yeah.
Okay, I think that you would plug
Yeah.
it. It just changed the weight after we do that. I thought it was gonna be equation or something.
That'd be
so long.
Oh, very good, very good. This is your weight equation. This is weight.
Oh.
Weight is the force due to gravity on an object. That is the weight.
Okay, so you mass
It's always your weight.
Okay, so, okay.
So you just did it, you just didn't know that that was
I
the
just
weight
did it,
equation.
I just
So technically, we're actually not solving FG because the force would be the force that opposes FG. If that makes sense.
I get it now.
Yeah. For a computer scientist.
Have a shot.
I'm almost positive. I don't think I did.
You president or bodyguard? Secret Service.
I probably did.
Assassination.
It's all about the arrow.
Has he even said anything today?
Yeah.
What did he say?
Don't talk to me.
Like the ones that are like really nice and then they're Jen, get a picture.
I know. She came in and took a picture of me.
You're 20, that's supposed to be Thursday.
Yeah, I like that one, the last week, and then it went.
What that was question number 42, the answer is 42.
Hey, guess what? I'm old and I still love America.
That's it.
Danny's like, I was like, it's okay, like, sorry, I don't like to talk to you. But
He's a
talk to me, so I was like, you talk to me all the time.
All the time.
Wait, Ethan, so I'm confused why you have tape on you?
Because I'm a content.
You're a what?
I'm a content.
What's that to do with America?
There's crime.
I'm working on my marriage.
He's like, I just had a tape.
Yeah, I just had I'm the FBI.
I'm actually making it Wednesday.
Yes.
We will have 2 days of review. I know this class doesn't need it.
The other one does.
Well, that was the game.
Why do you have to wait till tomorrow to study?
Well, and we already studied for the quiz, so. I already studied on some.
Yeah, that's true. So what is that quiz?
Yeah, we studied everything that.
Good, that was the purpose of it.
Oh.
Mr. Kramer, you look beautiful. I'm stuck with the
Good, close.
I like it.
Up here.
Yeah, they are really.
Mine are a little smaller. The sound that it makes.
I like these because they're different. Why are you so like quiet today? It's
Because he's the secret servant, or are you the president?
He's not.
Oh, shoot.
These, your legs look really skinny. And then it looked like, yeah, that's what I was just saying. Probably because I'm cold.
Yeah, your knee is like.
Hi, you said.
No, stop.
Oh,
We're the same. No,
I don't think I'm all ready to hit the wall.
I put the mic on my mouth.
She's like, yeah, you don't like it.
Yeah, this year, right? Last
Is
year.
it like the object you get it?
But I can close down.
Wait, change them. I have.
Dude, I'm gonna pop that in a sec. Yes, I did.
Why are you gonna?
No, I'm never gonna let you see your quiz, ever.
we have quick.
We'll do a quiz today, pop quiz, whatever you
Yeah, we
want.
have to.
Really? I swear.
Oh,
It's a boy.
No, you were.
Alright,
We just had a test, so we're all full up on our English knowledge.
what test you have?
That was not English, that was
Short story. That was stupid. Literally.
How is that class?
It's bad.
It's not that.
And also the stories that
I
we
like
read about.
reading.
Yeah, right.
Well, if we're gonna
Well,
do space.
I don't like reading. I don't.
Yeah, me neither.
I wish I did, cause I'd be a lot smarter. Oh, I just like it. I'll do that. I'll do that.
Wait, that's our review sheet? Worksheet.
Here you go, Rose. Phone away, please. What?
She's just so you too.
Thank you. I feel like I should just walk around like this.
I swear I'll get a picture of that. People in the street.
No, please let us.
No, could you walk like that again?
You can't just do it off command. It's just natural.
And do it on.
You have it to go. You can do it. Are you gonna dress up for Wacky Wednesday?
Will I?
Yeah.
Probably.
Yeah.
What are you gonna do for church?
I don't know. Church, that's a dumb one.
Yeah.
No, I'm bringing a suitcase with my backpack all around my pocket. And my postcard collection.
Okay, well I don't have a postcard collection, so.
And I have a press clipping collection. I'm gonna bring binoculars and telescope. Well, camera. Because that's the
Feels
mass
so
number.
nice. Ugh.
Yeah, the mass number.
This is carbon. Carbon is how I, six.
Oh,
Six how I remember all people. How'd you get Helen?
Hey, you're real quiet.
He's a bodyguard.
Weird feet. All the people in, for the people in England did that. Quiet.
You're a bodyguard,
It's a huge
huh?
honor.
Oh,
I know. Fair.
Impressive. You keep that up. Why is that chair upside down?
I have no idea. I saw it up with that.
I felt that.
Like that?
Yeah.
That hurt.
Whoa!
Oh, yeah. That's big. Yes. Yes. Take a picture. Oh my gosh. I need my
My
phone now.
full.
Please be
Rip.
charged.
No, you have to be.
Please still be 1%.
Oh yeah, you gotta stand on top of that.
Yes! Oh my gosh! Oh my gosh! Oh my gosh! Do that again now. I'll still take a picture of that. Look at his face.
Your answer's zero.
I got a picture of his face. I think you should stand there for the next class. The photo.
What is that?
Walk down the aisle again.
That's
Oh no, don't make him have to.
Ooh.
Switch.
Ah, he's wearing a helmet.
Silent ball.
Yeah.
Silent ball with the stress ball.
Oh my god.
We'll fall.
Alright, we'll see. We can get your stuff done.
We should have did it with my
Since
stuff.
you got 100, I will use yours as a key. Ah, there was a lot easier than 100. I wish I could see that for a different class.
I wonder
Number 1 is B. Number 2 is D. Number 3 is nucleons. Number 4, the identity. Number 5, the number of protons. Number 6, 16 over 7, nitrogen. And then C, and then 6, 6, 10.
Oh, I wrote that. I'm confused. Oh, you got the top one wrong. How did you do that?
Questions? Protons, electrons should always be the same amount. Neutrons is going to be the one that's different usually. Any questions?
Is there a number that's all of the subatomic particles in an atom?
All of the number of.
So like.
No. 5. The question 5.
How many baby burner?
The number of protons.
Oh my.
Oh, he even puts his pen in Spanish.
No, our goal is to make him laugh at the end of the day.
I got a smile.
Oh my gosh, you smell!
So, are you a bodyguard of like the president?
Just not.
You don't
I thought
talk?
he was
You're not supposed to
Bodyguards
avoid
can
it.
talk.
Where's your earpiece? At least nod. Can we do yes or no
Alright, fine.
questions? Fine.
I'll take that.
Presidents talk, so you must be Secret Service.
Secret Service talk.
No,
What?
except in English.
What again?
What about the Secret Service?
No.
But they're the palace guards, and it's like you have to make them laugh. Well, you have to try. Sometimes if you get too close to the gate outside, you get well. And I feel like if you just walk through the room, they don't. Probably not.
He smiled. He smiled.
They broke it.
I think the one I got was so much better. Mr. Kramer, I got some beautiful pictures of you.
Yes.
Got my phone.
Espin!
That's nice. Oh yeah, I got a notification on my watch, but I didn't know.
So this may look familiar, but it's not as familiar as you think.
Because there's a backside.
Yes, maybe so. Oh, it's a review. Okay.
It looks just like the quiz, except for I changed it. Like, you didn't even take a picture of the tutu.
Oh no, I did. This is one of the pictures.
I just need to crop.
This is the tutu picture. Why
Okay,
why
so
does my camera look so
the reason why I say this is actually a template of what the quiz looked like. I just changed all the questions except for one.
Alright.
Okay, then there is a backside. No, test will be longer, right?
Oh.
Guys, anytime I do a review, I don't put every little thing on the review. So there is stuff that will be on the test that's not on here. That is either out of your reading, or out of your notes, or out of what I have talked about in class. Okay? All three of those things are important. So I will do a key here quick. I have not. I just made this up this morning, so I will do the key. Now, if you have issues with anything, come work with me versus just looking at the key and trying to figure it out on your own, because I can usually figure out where your issues are. Fluorine is F.
I'll have my regular line.
I think I spelled that wrong.
What is it?
Nucleons. I think I spelled that wrong. I did nucleons.
Yeah, I do that all the time.
Because I always think about neutrons.
Wait, number 3.
I shouldn't just toast the answer to that.
Isn't that the answer?
Yes, I just spelled it wrong.
Oh. Wonder how many people put that down.
Yeah, absolutely.
Oh, right.
Yeah.
Oh, yeah.
What's that number next to GA? Is it 30?
What?
31. No, 31. Yeah.
31? this is president of neutrons. That's the atomic number. What?